Alright, my dears, I thought we would take a look at these last two practice problems here. Let me just grab a calculator real quick. And if you need to see the work from the previous problems, here it is. In case you were absent, take a look. So to do stoichiometry, you're going to need a periodic table, a calculator, and it helps to have one of these where do I go next cheat sheets, but you don't need it. You will learn how to do it, and you'll remember. So here we go. Our next problem, let's adjust that so you can see. There we go. Our next problem is KNO3 breaks down to yield K2O plus N2 plus O2. Okay. So that's our equation. What do we think? Is this balanced? Before we even read the problem, that's what I want to check. Got one of those, two of those. Okay. First thing we need to do is balance this problem. So I'd like you to pause and go ahead and balance this problem on your own. So what I would do is rewrite it. KNO3 yields K2O plus N2 plus O2. Draw a line, list all the things I see: potassium, nitrogen, oxygen, potassium, nitrogen, oxygen. I try to list them in the same order so that I don't get confused later. 1 potassium, 1 nitrogen, 3 oxygen, 2 potassium, 2 nitrogen, and then 2 oxygen over here and 1 over here makes 3. Okay, this is not looking terrible. Oxygen's already balanced. Let's start with this K. Alright, so we're going to put a 2 here. So now everything in that chunk after the 2 is multiplied by 2. So that means we've got 2 of these, and 2 times 3 is 6 of these. Alright, so now this is balanced, and the nitrogen's balanced as well. We've got 6 oxygen. We've got 3 over here. What can we do about that? Interesting. Well, it feels like we should be able to just put a 2 or a 3 right here, right? Because 3 times 2 is 6. But don't forget about this little guy over here. He's causing problems because we have to count this oxygen as well. So what should we do? Sometimes when I have issues with odd numbers, I just multiply everything by 2. So this becomes 4. So now we have 4 potassium, 4 nitrogen, and 12 oxygen. We put a 2 right here. So now we have 4 potassium and 1, 2 oxygen, but we're going to wait on that because we have to multiply everything else by 2 as well. So 2 nitrogen times N2 is 4 nitrogen total, and then 2 oxygen from here plus 2 times 2 is 4, so 2 plus 4 is 6 oxygen here. There we go. Now we've got numbers that make a little more sense. So the potassium and the nitrogen are balanced, 12 oxygen here, 6 oxygen here, 2 of them over here, 4 of them are here. We want to come to a total of 12. So I can't do anything about these 2 oxygen over here, so let's do 12 minus 2. I need to make this 10 oxygen. So put 5 here. Now we've got 5 times 2 is 10, plus 2 more oxygen over here. That's 12, and that's balanced. All right, if you weren't following that, go to the practice Padlet. Actually, you're probably already there because that's where this video is. And do some practice balancing equations. But let's copy this final reaction here. 4KNO3 yields 2 K2O plus 2 N2, that's nitrogen gas, plus 5 O2, that's oxygen gas. All right. Now that this is balanced, we're ready to work through this problem. So let's see what they're giving us here. We have 240 grams of K2O that are produced. Ooh, and it's asking us how many grams of oxygen will also be produced. That's a fun problem. So we're getting grams of something, and we want to know grams of something else. You can't go straight from grams of one thing to grams of another. You need to go grams to moles to moles to grams. So let's do that. We know that we have 240 grams of K2O. And we want to know how many grams of oxygen are produced. So 240 grams of K2O is our given. and we need to convert it to grams of oxygen. Now, we can't convert them straight from grams to grams, but we can do grams of this to moles of this, moles of this to moles of this, and then moles of this to grams of oxygen. These numbers here, you can pretend that all of these mean moles. 4 moles of this yields 2 moles of this plus 2 moles of this plus 5 moles of this. So if we want to convert from grams of something to moles of something, the way we do that is a molar mass. We need to figure out how much does 1 mole of this weigh, because we're going to go from grams of K2O to moles of K2O. We can do 1 mole of K2O. How many grams does that weigh? Well, we can figure that out. If we look at our handy-dandy periodic table, we see that potassium, each mole of potassium weighs 39.10 grams, and we know we have 2 atoms of that, so we're going to put times 2, plus the oxygen. Oxygen over here weighs 16, so plus 16. So that'll give us the weight of it. Let's do this. Ready? 39.10 times 2 plus 16. And I'm going to tell you, I might be going too fast for you. Please pause the video. You do not have to do this all at my speed. But remember, I've been doing this a long time. So that's why I'm recording this, so that you've got the option to pause. So if we add these all together, we get 94.2 grams of K2O in each mole of K2O. Now, we actually don't care about K2O. We want to know grams of oxygen. If I was able to make this many grams of K2O, how many grams of oxygen did I make? This might matter to know how much oxygen was released to the air. So, can we go from moles of this to moles of oxygen? Absolutely. That's what this reaction is for. So, we've got moles of K2O up here, and we're going to have moles of O2 up here. So, we know that we can convert from moles of one thing to moles of another because we have this, but how many moles of each? Well, that's what these numbers are for. 2 moles of K2O produced means that we also produced 5 moles of O2. This is like a recipe. If I put 4 of these in, I get 2 of these, 2 of these, and 5 of these. So if I got 2 molecules or moles of this, I must have gotten 5 molecules or moles of this. So, got grams to moles to moles. Grams to moles to moles. Let me get back to grams. So we're going to look at the molar mass of the second thing over 1 mole of the second thing. You can use this as kind of a cheat sheet to figure out what your next chunk of math is going to be. But you can also just use logic. If we've got moles up here and all the units have to cancel, we're going to have moles of O2 here. And can you convert from moles of O2 to the thing we actually want, grams of O2? Of course you can. Once again, that's a molar mass. So how much does 1 mole of O2 weigh? Well, we already know that oxygen weighs 16, and you don't have 1 oxygen atom here, you have 2. So, I actually don't do any mental math in chemistry because I'm dyslexic, so I make a lot of errors. 32. Some of it I do, but mostly I use the calculator. Alright, my dears, let's check our units. Grams of K2O, those cancel out. Moles of K2O, those cancel out. Moles of O2, those cancel out. And we're left with grams of O2, which is perfect, because that's what our problem asked for. Alright, so let's do our math. On these calculators, the easiest way to do this, I'm trying to move it so you can see the numbers, is just to multiply everything across the top and then divide by every number on the bottom. So 240 times 1 times 5 times 32 divided by 94.2 divided by 2 divided by 1. Of course you could skip the ones, but where's the formula? Alright, we got as our answer 203.82 grams of O2. That's how much is produced. Now, let's take a look at our answer key. Do we have a best answer here, a closest answer? Yeah, it's C, 200 grams. Is it exactly what we found? No. So I might go back and check my math and make sure I didn't make any errors here or type anything wrong. But remember that in chemistry, all of these values are experimentally determined. Okay? So experiments are the reason we know these. maybe somebody's values for these are a little different, maybe these values are a little old, so it's not uncommon to be off by a little bit in chemistry. So pause here. I want you to try this next problem on your own. It's already balanced for you, I'm pretty sure. So, all right, we're going to move through this one a little bit faster because I don't want this video to get super long. I'm going to do these maths one chunk at a time, and I want you to pause between each chunk and try to figure it out yourself. Okay, so for the first chunk, I want you to figure out what's my given. What am I starting with? This one's a little tricky. We've actually got two givens here. We've got 660 grams of chlorine reacted with 67 grams of H2S. And we want to know how many grams of S8 will be produced. So this is actually a limiting reactant problem. If you open up your notebook, you can take a look at page 100 and see what's going on here. But basically, we're saying, I've got this much of this and this much of this. How much of this am I going to make? Are these perfectly balanced? Or is one of these going to run out first and limit how much of this I can make? That's what's going on. So we're basically going to run this chunk of, or this, twice. So let's start with Cl2. My starting is 660 grams of Cl2. And in all these problems, I'm going from grams of one thing to grams of another. But we can't go directly, so we got to go grams to moles to moles to grams. So pause, figure out your next chunk of math. And when you're ready, press play and it will magically appear on the screen. All right, did you find a molar mass conversion was necessary? I got this number by figuring out how much chlorine weighed and multiplying this number by 2 because there's 2 chlorine atoms in each mole of chlorine gas. So we've gone grams to moles. What's next? Figure it out, press pause, and then it'll again magically appear. All right, did you use the equation to do a mole conversion from moles of chlorine gas to moles of S8? If so, great job. If not, remember, anytime you're going moles of one thing to moles of another, use your reaction. So remember, we're trying to get to grams of S8. Go ahead and pause, see if you can figure out the next chunk of math, and then once again, I will reveal it. All right, I wrote this a little funky, but there it is. S8, each sulfur weighs 32.07 grams. I multiplied that by 8 because there's 8 of them. So that's how much 1 mole of sulfur weighs. So now we're ready just to multiply across the top, divide by the bottom, and figure out how many grams of that weird sulfur compound we can make. So go ahead, pause, do your math. Did you get 298.54 grams of S8? That's what I got. Hopefully you got it right. Hopefully I got it right. So if you have not been pausing in between these chunks and figuring them out, I'd like you to try it when we do our 67 grams of H2S. You've got these as a guide. We're going to do a very similar thing. So we know for our second stoichiometric problem, we're trying to figure out how much S8 can be made from 67 grams of H2S. So I'm going to start out with 67 grams of H2S. I want you to pause and figure out what your next chunk of math is going to be. Remember, this is going to look a lot like the problem above. All right, hopefully use the molar mass to convert this to moles. And I got this molar mass by accounting for the weight of my 2 hydrogen atoms, found that on my periodic table, and adding in the weight of my 1 sulfur atom. So there we go. All right, what's your next chunk? Did you use the equation, the chemical reaction equation, to convert and see that 8 moles of this reactant will produce only 1 mole of this product? So, very nice. Last thing, we got to make it all the way to grams. What are you going to do? I hope you just used the same molar mass above and didn't calculate it again, but if you did, it was good practice. So there we go, there's our chunks of math. I'm going to multiply all the way across the top, divide by everything on the bottom. Pause your screen, do the same, get that practice in, and here we go. All right, here's what I got. Yes, if we had infinite amounts of this, 660 grams of chlorine gas could make us 298.54 grams of that S8 compound. However, we don't have infinite of this, we only have 67 grams. And that is going to run out first. We're only going to make 63.03 grams of that sulfur compound. This is a little bit like running out of chocolate and having plenty of marshmallows left over. So If we're going to run out of this first, once we run out, this grinds to a halt. So we're only going to make 63 grams, and that is answer choice A. All right, my dears. However you're feeling on this, the next thing for you is to take a look at that practice Padlet. You can choose either to watch a bunch of videos to help you understand this more deeply, watch a bunch of examples, or you can jump right into the practice column and just start doing practice problems. Either way, use the rest of your time for that.